All right, we are live on YouTube now, Hemant. If you're ready, we can begin.
I think Mr. Hemant should unmute.
Thank you. Good evening. Welcome, engineers, to UAE Regional Group CPD Talk for November month. Thank you for attending our last CPD on health monitoring system on concrete at American University of Dubai. We have joined today by two specialists in the field of concrete. Before I introduce, we are thankful to our gold sponsor, Hempel Paints, the protective system for structural steel. They are a leading supplier of both fireproofing and normal coating. We are also thankful to our sponsor, Arabian Gulf Steel Industries. They have a vision of zero emission steel in the Middle East. Today's talk is on building green, the sustainable and economic promise of concrete. We will introduce our first speaker, Dr. Mustafa. Dr. Mustafa, he earned his doctorate research PhD from one of the leading University of Edinburgh, UK. He is a founder editor of a leading journal from Center of Excellence in Smart and Sustainable Construction. He is a guest editor at Materials Journal, which has a score of 6.4. He has published more than 40 technical papers and he is supporting the young researchers through his dedicated review. He is also attend like keynote speaker and panelist on various panels. Let me share his talk on the route to membership through research has received highest number of click on our YouTube. He is also supporting Syrian Engineers Syndicate in Damascus and many other such associations. Now we would introduce our second speaker, Dr. Yara. She has 7 publications and masters in seismic research, seismic studies and research from Damascus University. She is a lecturer at Heriotbet, Dubai, a professional structural engineer, and has 7 publications on her name in structural engineering and concrete material. Today, we will get benefited from these two specialists in the field of sustainable concrete. You will be surprised to know the concrete is the second most used material on planet Earth and it is number 1 in construction. So please join me. Welcome Dr. Mustafa and Dr. Yara.
Yeah. Thank you, Hemant, and thank you, Basil, for welcoming us here. And I mean, what you said about us, I won't say that. Okay, so let's go with our presentation right now. So let's start with some facts about concrete. So concrete is old material. So it was born in 1849 And concrete has many advantages which make it number one in the construction industry. Some of these advantages, and not limited, as that it's cheap construction material and it needs low maintenance costs, and it's very easy to shape because it's liquid material. And moreover, it needs less skilled labor and it's fire and weather durable. And let me tell you a fact that the concrete is sustainable material compared to other materials. So for example, here you can see that each ton of concrete produced or has embodied carbon of 100 to 200 kilograms CO2 emission. While, for example, if I compare it to steel reinforcement or to hot rolled steel section, it has 2,000 kilograms per ton. And if I compare it to more sustainable steel cold form section, so the cold form section has 600 kg CO2 per ton. So you see how concrete is very sustainable. And concrete as well is proud to rank globally as the second consumed material after the water, and its production these days reach to 20 billion tons per year. But however, with all this advantage the concrete has, I can say that there is some disadvantage of this material. First disadvantage that is the cement problem. So because the concrete depends too much on the cement, and the cement is producer for the CO2 emission, so the production of the cement produced can produce up to 1,000 kg CO2 per ton. And I'm not happy, if you look at this figure, I'm not happy to say that by 2050, the production of the cement may reach to 5 billion ton. So from here, the problem of the emission of concrete comes from the massive production of the cement, actually. Moreover, let's talk about the UAE here. So if we look at this graph, and this graph gives the CO2 emission per capita, you can see that the UAE come at first from the country produce the highest CO2 emission per capita. Why? Because the UAE is a producer for the cement and export the cement in the area. So for example, per year, the production of the cement in the UAE reached like 40 million tons. And because of that, the UAE is now number one in the CO2 emission per capita. The another problem of the concrete is that our concrete is feeding on our natural aggregate. So for example, in 2015, you can see that we required aggregate for concrete as 48.3 billion ton. And you know that the aggregate in concrete counts like 75% of the concrete. And this number is projected to increase to 5.2% yearly. The third problem of the concrete is that the concrete produce construction and demolition waste, a lot of construction and demolition waste, which was estimated to be like about 1.1 billion ton per year. And this produce landfills. So with these three problems I mentioned before, we can classify the concrete as non-eco-friendly concrete. And let me tell you that the concrete contribute to 8% of the global emissions. So that was the disadvantage of the concrete. But let me tell you something, that we can turn the concrete to be a cure for our world sustainability. How we can do that? Here is the concrete, which is non-eco-friendly material. Actually, the concrete can take all the waste, approximately all the waste on our planet. So for example, we can if we take the cement and we decarbonize the cement, and in some cases you will see that we can use the industrial waste industrial product waste instead of the cement. So that will be great. And as well for the natural aggregate as well, we can reuse recycled waste, and at the same time we can use the construction demolition waste as aggregate as well. And by this way, we can turn the concrete to be eco-friendly concrete. There is rank for concrete. So you can see that this rank comes from the ICE booklet. So it ranked the concrete from class G, which is the most so this concrete here has the most embodied carbon, to A++, which is the most green concrete. So now there are many practices to create sustainable concrete. The first three you can see from these practices here. I'm offering like 9 practices to turn this concrete to be sustainable. So the first 3 practices is simply to replace the cement by other material, and mostly the industrial product waste. Like, for example, we can produce the novel cement approach like geopolymer with 0 cement, and I will talk after a minute about the geopolymer concrete. Or we can decrease the clinker to cement ratio by supplementary cementitious material. And this, for example, in Europe now, they are replacing the clinker by 74% of supplementary cementitious material. And in China, they reached to 65%. And as well, producing low carbon concrete. But with these 3 methods, we have challenging here because we have limited availability for the industrial waste like the GGBS, silica fume, fly ash, and I will talk after a while about the ceramic waste. We have as well that the energy efficiency, like replacing the old clinker with more modern clinker kinds. And as well, we have carbon capture and reuse, which is the future, I believe. But we have problem here that these 2 methods will cause increasing in the electrical energy. And they found that these 3 methods up to now, they are not economically efficient for cement industry. So sometimes the market reviews to use these 2 methods. We can use in our kinds alternative fuels like biomass, but the problem is that the biomass itself is limited to specific regions, so this will bring cost inefficiency. Some countries apply tax to the concrete, like for example, we can see that in Europe, they apply 20 euro per ton of the CO2 emission for the cement manufacturer. But actually here will cause a high cost of the cement production because the cement manufacturer will add this value of this tax to their product. One of the, here the method as well, to use sustainable construction method, like for example, precast of 3D concrete printing. So at that time you produce less waste. And as well, I need to add that optimization in the design is so important to reduce the use of concrete. The future, actually, maybe we see that's advantage of using the carbon capture and reuse method, because if you want to obtain like zero CO2 emissions, so you need to use this method. So you capture the carbon and you use it in other, for example, chemical products. As I said, that the concrete can be can clean, let's say, can clean the waste in our planet and reduce the landfill. But so what is the recycled waste? Actually, the concrete can take, as I said, most of the recycled waste in our planet. I will explore some part, and I worked personally on this part. Like, for example, glass. The glass, the world produce a huge quantity of glass. So the damaged glass, like for example, in the USA reached to 2.3 million ton. Or sorry, the production, 12.3 million ton, and 8 million ton was landfill. So all 68% of this production was landfill. The UAE produce, I mean, less glass and less waste. Why? Because in the UAE, you know that in most country in like the US or USA or Europe, they like have or drink a lot of beers, not like the UAE. So from here, the maximum capacity in production comes. We have the ceramic. This is very important material, and it has a lot of waste. So for example, the ceramic tile production globally reached 13 billion meters square. And in the UAE alone, RAK company has the capacity to produce 123 million meters square. And let me tell you that always 30% of this production come as a waste. Why? Because of the transportation and because of the manufacturing process. So during the manufacturing process, you will have a lot of damage. Ceramic waste powder, which is very promising material to be used instead of cement, partially, absolutely partially, I'm talking, because you cannot replace the cement fully with this material. So do you know that each meter square of tiles produce the 19 kilogram of ceramic waste powder? The ceramic waste powder, just to tell you that it produced during the polishing process of the tile. In the UAE, it's estimated that the quantity of this material reached 2.5 million ton, and this is very dangerous material. It's very fine material, and it can go to ground and air and water. So it's very dangerous material, and the concrete is the best product can take this material and save our planet of this chemical dangerous material. Ceramic demolition waste as well is big issue all over the world, and we need to free our landfill, and the concrete is the best product can take the ceramic demolition waste. Plastic, we all know the problem of plastic. So for example, the world produce like 380 million ton of plastic yearly. 80% is landfill. The recycling of plastic, by the way, not exceed like about 17%. By this way, we will reach 2050 with 12 billion ton of plastic waste landfill. So the concrete is the best product to take this waste. Let's look at these two charts, because here you may raise a question here. So which waste I use most? Actually, it's very good if you use the local waste. So for example, if we look here globally at the waste, we can see that the construction and demolition waste count 86% of the waste. The glass count just only about 3.5%. The ceramic waste globally, I'm talking globally, it's count 1.62, while the ceramic waste powder count 8.5%. But if we look at the UAE, we can see that the construction demolition waste come first at 89%, and the ceramic waste powder comes second at 33%, percent. So it's preferable that you use the ceramic waste powder because it's local product. So you don't need to import other material from China or India, because this will add extra cost to your product. And our aim as well to offer the market is not just the sustainability, but to offer the market as well cheap material, to convince the market to use this material actually. I can say that to achieve sustainable concrete, you need to achieve the Fantastic Four. It's not the movie, the famous movie about the Fantastic Four, but I can say that the Fantastic Four is saving natural resources, reducing landfill, reduce the CO2 emission, and confirm the low cost of this concrete. At that time, I can say that this concrete is a green concrete and economic concrete as well. I will take you now through some research conducted at Heriot-Watt University. So the first research that we have natural aggregate and cement, and we replace the natural aggregate by 100% recycled coarse material coming from the construction and demolition waste. And this recycled coarse aggregate are produced, that we use here, are produced in BIA company in Sharjah. As well, we take the natural aggregate as well, the fine natural aggregate, and we replace it with ceramic fine aggregate. So we take the ceramic tile and we crush it until we obtain the fine aggregate from this ceramic tile. And to replace the cement, we replace in this project as well, we replace the cement partially by ceramic waste powder. This work is published, by the way, here is the publication, and this work was funded by Expo Life 2020. And here is the result of this research. You can see that here we have 8 mixes, and you can see here we are comparing the property of this product with the conventional concrete. So as you see here that the final mix, in this final mix, we replace the coarse aggregate by 100% recycled aggregate, and we replace the fine aggregate by 20% of the ceramic fine, and we replace the cement by 20% ceramic waste powder. The result was very promising. So you can see that we obtain high quality, by the way. The compressive strengths here reach like 50 megapascal, but at the same time, we approach 22% reduction in cost and 23% reduction in the CO2 emission. Moreover, here we replace the component of the cement by 40% of the recycled waste, and this is great. So at that time, we can free our landfill. This product, if we compare it with the rank of the ICE that I talked about, we can see that this product reduce the rank of enhance the rank of the concrete from grade E to reach grade B or rank B according to the ICE ranking, with keeping the quality high and reducing the cost. So that was very promising product. You can see, you can read more about this product in this article, which is offered, by the way. It's open access article, so you can read more and read further about this research. As well, we work on the geopolymer concrete. In geopolymer concrete, in our trial here, we replace the cement 100% with the GGBS. So we were able, by this replacement, we were able to reduce the rank of, or to improve the rank of the cement from grade E based on the on ICE ranking to be A+. So you see how the improvement here. But actually, we face two problems here with the geopolymer concrete. First of all, the low workability. So this product, because we designed this product to reach 40 megapascal actually. So because of that, it has low water quantity. And when we apply the superplasticizer here, the superplasticizer go against the additives, because in geopolymer concrete we need to add activator. So we add we added two activator actually, sodium silicate and sodium hydroxide. The sodium silicate work against the superplasticizer and stop its work. Because of that, I can say that the geopolymer concrete can be used with low strengths, because in low strengths you use like a percentage of water compared to the cement like 0.6, 0.5. But here in our mix, we use about 0.33, and stop working of superplasticizer give low workability. But the most disadvantage of this product, that the cost of this product come 5 times than the conventional concrete. So you cannot convince the market to use this product. So that's the problem. So until we find like a product, a geopolymer concrete with low cost, at that time, we can say that we can use the geopolymer concrete. And the geopolymer concrete high cost come from the activator we are using actually. So the cost of this activator are too high in the market. And from here, the cost comes.
Yeah, thank you, Dr. Mustafa. So yeah,
So
I'll
I
just
will hand over now just to Yara to continue from here.
thank you, Dr. Mustafa. So the other research in terms of the sustainable concrete, it's the one that we did in 2021. It was part of my PhD. So another replacement was the full replacement of the recycled coarse aggregate of the natural aggregate by the recycled coarse aggregate. And it was like locally generated from BIA company in the UAE. And for the cement, the replacement was 50% of GGBS and 10% of silica fume. But before this, this article was actually interesting because we didn't first have the decision of the full complete or the full replacement of the recycled coarse aggregate. Before that, we did lots of literature. And if you can go next. So there was like an extensive data analysis in terms of the literature, and we collected the data. One of them reached to 100 data about the mechanical properties of the full and complete replacement of the recycled aggregate concrete. And we studied we collected the mechanical properties as well as the durability from previous studies from 2007 until part of like 2020. So as you may see from the graph that according to all, or let's say an overall performance of the concrete, we will see that there's a spread of data, and this is like a given indication that the incorporation of a full replacement of the recycled coarse aggregate would definitely gonna deteriorate or cause a weak performance of the concrete and deteriorate the overall performance in terms of the mechanical and durability. As you may see, for the compressive strength, for example, it may decrease up to 37%, while the tensile strength can even reach harder than this. Even for the dry and shrinkage, for example, about the durability, the incorporation of a full replacement can increase the dry and shrinkage about 73%. So we can see that there's definitely a weak performance by the incorporation of the recycled coarse aggregate. But according to the literature, the incorporation of the supplementary cementitious materials like the GGBS and the silica fume at their optimum percentage and replacing that with the cement would definitely definitely gonna decrease or improve the quality of the recycled aggregate, as well as decreasing the embodied CO2 emission. So according to the article, we've done this is the proposed concrete mix, and as you may see, although maybe there was like insignificant improvement for the mechanical properties, and this might be attributed to the ITZ, the old ITZ that is adhered to the mortar of the recycled coarse aggregate. But interestingly, there was like a very improvement in terms of the durability properties, like the chloride ingress have dropped about like 80%. And while the dry and shrinkage have dropped about like 35%. And not to mention the dropping of the CO2 emission that compared to the conventional concrete, it dropped about the half of it. So if you go to the next slide, according to the ICE sustainability grades, so this proposed concrete mix was able to decrease the grade or the sustainability grades of the concrete from being F as a worst material way into the green part of it. This is the B level. And this gives this mix a good potential in doing a further research, and this is what we've done. So another research that we have done is the incorporation of the fiber in concrete. So we all know in general that incorporation of the fibers in the concrete may increase the, let's say, the tensile flexure strength as well, the fracture energy. But we focused on having the two combination of being sustainable and a good performance. So we incorporated the PET, which is the plastic fibers coming from shredding the water bottles, into the concrete. So this article was done by in 2024, and it was like an interesting one because we have found, if you can go, please. Next. So we have started doing the actually focusing on the optimum content of a fiber in the concrete, which is the most challenging part, because this optimum can boost or can maximize the benefits of the performance of the concrete by incorporation of the fibers. So for this one, we have done a literature, and then we have found that it's the volume fraction of the fiber actually in the concrete was not the dominant role for this one, but there's like a combination between the fiber geometry and the volume fraction. So the combination of them give us the optimum kind of quality of the fibers, where we can see here, according to many trials with different fiber geometry and the volume fraction, we were able, by using the optimum fiber index, to increase. Can we show the so to increase the fracture energy to the maximum, and this is reflected by the area under the stress CMOD graph, which can we see this one. It's interesting to know that even for the durability properties, the use of the optimum fiber index, which is a combination between the good geometry and the good shape, as well as the volume fraction, was able to decrease the dry and shrinkage by up to 43%, which is interesting and give potential to this kind of mix to be incorporated. So we extended the research, and we have casted even like just to check the structure performance of this kind of mix. So we extended the research, and we have casted, can we go please? We have casted small shear critical PET fiber reinforced concrete beams. And it's interestingly to use the optimum fiber reinforcement in terms of a geometry and a volume fraction. So we were able to have resulting the, let's say, to lessen or to reduce the brittleness of these kind of failure modes, which is a sudden, and to delay the crack pattern in terms of decreasing the sudden failure. And this is so beneficial for saving lives when we incorporate the fibers and we decrease or delay the crack pattern, or maybe we can decrease or gives like more ductility and decrease these kind of failure modes, like a shear failure mode. So it's not only here, but as well we have, can we go to the next, please? So the first one was incorporating the PET without any shear transverse. But even if we incorporate it with the minimum shear reinforcement, so if we incorporate the PET fibers in a beams where we have a minimum shear reinforcement, so the PET was able to even increase the capacity of these kind of beams more than the without even adding any additional transverse reinforcement. So increasing the capacity with the minimum shear reinforcement, and this is would give like like the close the loop of sustainability, because if we don't need additional or extra shear transverse reinforcement, then we will be able to save some steel and some reinforcement. So this is let's say a beneficial loop of sustainability with the incorporation of the PET fibers. And we're still like going further in this kind of research, because it gives potential in the future research, and we're just advancing and developing this kind of research now, and like aiming to publish more, because these two mixes, they do really have a potential in terms of a concrete mechanical properties as well as the structural performance. So far, these are the researchers, and if we go, so these are the next the references for the researchers that we have done. And thank you so much for listening. I think we are ready to answer any questions if there's any.
Yeah, thank you so much. So we are happy to answer your question. And as Yara said, that we are continue forward with producing sustainable concrete at Heriot-Watt University here. I mean, we are engaging, and we have like now a project as well. So our aim always was to reduce the landfill, to use the local material, local available material in our concrete, because this is the only way to reduce the cost if you use the local, and as well to reduce the CO2 emission deficiently. So thank you so much. We are happy to take your
Thank
question.
you.
Thank you, Dr. Mustafa and Dr. Yara. We have first question, like thanking for the presentation, and our attendee, he is looking for research opportunity at the university. So, like if someone wants to approach Heriot-Watt for research in concrete, or possible opening to support as an assistant professor, so how he can be in a contact with you, Doctor?
Yeah, thank you so much. You have my email, and you can send me an email, and we can discuss further about this opportunity, either in research, so as a PhD student, or as assistant professor, but that depends on the availability of the job here. So just send me email, drop me an email, please.
Thank you. And let us check, like the talk is live on YouTube also. We have like someone from YouTube channel. Let me find out if we have a question. But we had a very detailed presentation. The sustainability, it has a 3 pillars: social, economic, and environment. We found from this research, you touched all the 3 aspects: how to reduce waste, how to bring down the cost. I still remember the fantastic the 4 things which will support the 3 pillars of sustainability. And here we have a first question. I believe the plastic fibers can be a good technique and can be a mass adopted for slabs compared to column and beams. What are your thoughts? Can we take it to the local market? Yes, like Dr. Yara research found, it brings ductility into the concrete, and like in seismic reason, we always look forward a concrete which will deform more before giving up. So
Yeah.
please, Doctor.
Yeah. So please just, I mean, the audience to understand that usually we use the fiber to resist shear, not bending more. Okay, because for the bending, we have longitudinal reinforcement to resist the bending, but for the shear, the concrete work alone. So when we add the fiber, we enhance the shear resistance. And because of that, this is very beneficial in foundation, for example. So when you do like pile cap or the flat foundation, so at that time you reduce by adding this fiber, you reduce the thickness, for example, of the foundation, and at that time you reduce the cost. So it's mostly we use the fiber to enhance the shear resistance rather than enhancing the bending resistance.
Thank you.
So by this way, just to add that what Yara ended the presentation, that by this way we reduce the reinforcement needed for shear resistance, like stirrups. Okay, and by this way we reduce the CO2 emission come from the reinforcement manufacturer as well.
Thank you, Doctor. And yes, your research work, which was supported by Expo 20, which brought clear understanding, like how the replacing and like use of recycle aggregate plays a biggest role. And like we will be sharing one Q&A, like to check our attendees focus. We will share a Google form which has a few questions, and we encourage all our participants to answer that question. So let me put in a chat box a quick answer and this session link. 1 minute, let me put. So which will check like how our attendees were active. And till that time, we will take questions from our YouTube also. So we have put the link in a Q&A block. So everyone, sorry. Or maybe Basil, can we share a QR code with, like I will share my screen for the QR code. Yeah, Dr. Mustafa, we have thanks messages on our YouTube page for both of you for giving detailed, insightful research and presentation. So thank you, our live audience joining on YouTube. And this complete technical presentation will be available on UAE Regional Group YouTube page. We will wait for maybe another 2 to 3 minutes for like new questions from attendees. Basil, we will be able to share a quiz with the present all the members, or maybe I will share the quiz which we prepared. So CO2 emission per 1 kg of concrete is 0.1 to 0.2 kg per CO2 per kg of concrete. The second question, Dr. Mustafa first research, the cement was replaced by which material? It was ceramic waste powder.
Yeah, many
Yes.
topic. Yes. So many topic replace the cement by many material, but actually we prefer the local material. Why? Because, for example, if you replace the cement with the GGBS and fly ash, this GGBS and fly ash will be exported from other country, and this export will add extra charge to your product. So by using like the ceramic waste powder, for example, as partial replacement of the cement will reduce the cost of the product. And that is the aim for the market. And the reduction of the cost can come between like 10% to 20%.
And the IC sustainability grade for concrete, it is from +A to G. Which concrete has a lowest emission? Like everyone should target to what grade? And our answer will be +A. +A should be a target to reach. And using the ceramic powder, the team of Dr. Mustafa, they reduce from E to B, which we saw in the presentation. The research carried out by Dr. Yara at Heriot-Waite, she used which bottles? It was aluminium, glass, metal, or plastic. So it was plastic bottles. So now just we have few more questions. And so yeah, we have a few questions. Can plastic fibers be used in a plain cement concrete, say grade 10, 20 megapascal for structural bedding? And if so, in what proportion? 1% or more, doctor?
Yeah.
Actually,
Yeah, you take this question. Yes, okay.
yeah, if you let me. So actually, the first part, I'm going to answer the first part and then the second part. So can be taken for the plain concrete. Of course, it can be taken. And there's like, it's not lots, but like a limited studies, they have taken the incorporation of a plastic fibers into the plain concrete. But the originality for us, maybe in the future, is that we incorporate it in maybe the recycled aggregate or the combination of the supplementary cementitious materials. But yes, we can take it for the plain concrete. And for the second part of it, which structure system, any element that the main failure mode is shear, it can be used for the PET fibers. And the third part of it, like what is the optimum? Was that the third question, right? The third part of it, like what is the optimum volume fraction? Well, actually, he can go to our journal article because it was so interesting. Because we found out that the volume fraction is not the dominant part of deciding the optimum fibers, but we came up with an index, which is the kind of combination between the fiber geometry and the volume fraction as well. And we indicated or highlighted what is the, let's say, the ranges of the combination between the two in order to have the optimum fibers and in order to maximize the benefits of adding these fibers to the concrete mix. So it's so interesting to know the optimum from our journal. He can refer to our journal.
Yeah, just I want to add to Yara, please, that if you want to produce a cement of low strength C10s 20, like what's here, so we know that this concrete is of low resistance to shear, so the plastic fiber will add more value to this concrete while cracking, because the low strength has low shear resistance, so adding fiber will enhance the performance of this concrete.
Yeah.
Thank you. Thank you, Engineer Ashraf, for joining us today. So next question we have from oil and gas industry. We have an engineer who is dedicatedly working in oil and gas, Wood Group, Engineer Nagaraju. His question is, to implement in oil and gas project, is the material readily available? And like what the most important time, always project manager, they ask like what is the delivery time or who can supply?
Actually, this material is, and most the recycled material are in research, and the research, and without the authority, you may not be able to use this material. Like, for example, now, if we talk about the authority that the UAE authority or Dubai municipality allow you to use the GGBS and fly ash, but who knows, maybe in the future, we agree to use other recycled aggregate, because without using recycled aggregate or not recycled aggregate, recycled waste, you cannot free your landfill, and you cannot talk about producing sustainable concrete. And if you don't use the local material like the ceramic waste powder or plastic bottle, you cannot reduce the cost. You cannot produce low cost concrete. So I believe that, so we are in conversation with the authority to take action regarding using the recycled waste in concrete more.
Thank you, doctor. So yes, like once we have a ready-made product which consumes this material, and that product can be utilized like curbstone or like blocks. So if it gets started in a like a controlled environment, and it can slowly come up to the mainstream. Is technically, we have very interesting question from our attendee. Is technically and environmentally safe to use treated industrial sludge in concrete? And what standards or tests must be satisfied before it can be considered a sustainable construction material? So, like here, the use of treated industrial sludge. So definitely, it should not create problem for steel reinforcement. Correct, doctor? Like if we are using any, it should have a chloride limitation on
Yes,
chloride, sulfate,
yes,
which
yeah.
are the main enemy for the reinforcement.
The reinforcement, yes, yes. Because of that, like for example, because of that, using plastic waste, I mean here plastic fiber with this industrial sludge, so will be helpful because the plastic cannot be corrode with this material. So that will be helpful. But in any replacement or any producing of sustainable concrete, you need to carry on tests. The normal test, it's not just about mechanical property, please. It's about the durability as well. So without confirming the durability, like low shrinkage or low chloride penetration, so you cannot use this concrete.
Thank you, doctor. And when we go for maybe use of GFRP or FRP, where we are replacing the steel rebar with another non-metallic reinforcement, we may get benefit. So with this, we have answered, doctor answered all the questions asked by our attendees today. The regional group is thankful to Dr. Mustafa and Dr. Yara for sharing their research to create a better world. They touched on all the three pillars of sustainable concrete, which is economics, social aspect, and environmental aspect. We found the curiosity, they kill the problem by understanding who is creating problem, the cement, the aggregate, and how we can reduce the waste from our earth. So we thank, our team thank from for the detailed presentation today evening. And attendees, please look forward for our this complete presentation is available on YouTube, so you can reach to doctor for any further question. And look forward, we will have a good lineup of presentation in year 2026. So with that, we thank you all. Thank you, doctor.
Thank you,
you.
Herman.
And
Thank you, thank
Thank
you,
you, Herman.
Basil and UAE Group. Thank you.
Thank
And
you,
we
sir.
are especially thankful for our committee member, Engineer Basil, working behind the scene to deliver, to make all the arrangement for today's CPD talk. Thank you, Basil.
Thank you. Thank you.
Thank you, Dr. Mustafa. Thank you, everyone. Thank you, Aaron.
Thank you all. Thank
Thank
you.
you.